So in today's class, we are going to discuss about some other operations in singly linked list. Okay. So first we have gone with a singly linked list, insertion operation, deletion operation. So insertion, we have three cases: insertion at the beginning, insertion at the middle, insertion at the end. Similarly, delete at the beginning, delete at the last node, delete at the middle. Okay, apart from that, today we are going to see another two more operations in singly linked list. So which are the two operations means? One is the searching, the other one is reversing. So searching the node in the linked list. Second one is reversing the given linked list. Okay, so what is searching? So searching, as I have already given here, so searching involves finding the required elements in the list. So that means you are going to find the what is the element, whether it is present or not in the given linked list. Okay, so what type of techniques we can use? As we all know, we have two types of searching techniques. One is the linear search, the other one is binary search. Okay, so what happens in linear search? So suppose what happens in the linear search, we are having only key element. So that means you are searching for a key element in the given list. Okay, so you search the key element with one after the other in the linked list. Okay, so linear means, so find the key element with the first element. If it is not matching, find the key element, compare the key element with a second element in the list. If it is not matching, again find the key element with a third element in the list. So that is called as a linear search. So linear means you are checking the elements one after the other. So key element is searched with first element in the list. If it is not matched, then you are going with a key element is checked with a second element in the list. So if it is also not matching, so next key element is searched with a third element in the list. Okay, so that we call it as a linear search. So linear search means you are going to match the key element with each and every list, each and every element in the list. Okay, so come for the binary search. Binary search means, so entire list is divided into two parts. Okay, so first the key element is searched with the leftmost part, and again if it is a element is not found, the key element is searched with the rightmost part. So that is the searching techniques we have. So one is the linear search, the other one is binary search. So linear search, the key element is being checked with each and every element in the list until it is found. Whereas in binary search, we are dividing the list into two parts. So first you check the element in the leftmost part. If it is not found, then check the element in rightmost part. So that is the binary search. Okay, but come for the case here. So here we can't divide the list into two parts, because the first node contains the address of second node contains the address of third node, so third node contains the address of fourth node. So you are not supposed to divide the given list. So for that purpose, you can't apply the binary search for the searching in singly linked list. So what is the concept? Why you can't apply binary search means, because each and every node is linked to each other. That means the second node address is placed in first node. So third node address is placed in second node. So that's why the link is established between each and every node. That's why we can't perform the binary search, because binary search divides the list. So dividing the list will not happen in linked list, because each and every node are related or attached to each other. Understood? That's why we can't apply binary search for linked list. So keep in your mind. So that means we can't apply, we can't apply binary search. So we can't apply binary search in singly linked list. Keep this one in your mind. So you can't apply binary search in singly linked list because you can't divide each and every element. Understood? Getting? Are you getting? Kindly respond here. Hima, kindly respond. Are you getting or not? Okay, so that's why we can't apply binary search because you can't divide the linked list. So which searching technique we can apply? Keep in your mind, you are going to perform linear search. So we can apply the linear search because in linear search we are not going to divide the elements. So we are not going to divide the elements or a linked list into parts. Okay, so that's why we have taken it as in case of linked list, since random access is not available, it would become complex to do binary search. Therefore, we can perform simple linear search traversal. So what is the simple linear search traversal that we will see in this particular code? So this is the code what we are going to search. So in linear search, each node is traversed till the data in the node matches with the required value. So keep this one in your mind. So we are going to each node is traversed till the data in the node matches the required value. So what is that required value? So required value is the key. Okay, so this is the key value. So first you start with a search. Okay, so initially whatever the thing you take, so that will be considered as temp. Temp means, so temp is nothing but a key. Okay, so temp will be considered as key element. Okay, so temp we give it as temp is equal to start. So what is the temp value? That is the temp is equal to start. If temp not equal to null, so if temp not equal to null, what you will do? That means if temp, not, which is the null part, it will be the address part. If there is no list, okay. If temp not equal to null means, so it is containing some link. So where you get null in the address. So if it is null means there is no next node. Next node illa andre. Okay. If temp not equal to null, then temp then data double equals x. Okay. What is temp then data double equals x? So now you have to compare each and everything. So this is the condition what we give. Okay. If temp not equal to null means, so then you compare temp then data double equals x. So what is temp then data? So you are comparing it with first element. First element is x. Okay. So temp then data double equals x. So found temp then data. So this is the code what you are going to give to check. This is nothing but linear search. So linear search, you can give it as if key double equals a of I. Okay, so what is key? Key is nothing but, I have already told, temp is nothing but key element. If temp not equal to null, so temp then data. So temp then data is nothing but the key element equals x. X is the first element in the list. So which is the first element that you can take it. Okay, so or you can go with or if a of I double equals key. Okay, so a of I, so take any node. Okay, so if a of I double equals key, or you can go with key double equals a of I. Okay, so now you can go with temp then data double equals x. That means you are checking with key element with the first element, key element with the second element, key element with the third element, key element with the fourth element. So that's why we take it as found temp then data. If not, if temp then data not equal to x, then you move to the next one. So if the first node, that means if key double equals a of 1, a of 0 you take it. If a of 0 is not matching, so what it should go? It should go with a of 1. So how to move to a of 1? So first a of 0 is taken as temp. Temp is equal to temp then next. So that means it is moving to a of 1. Okay. So now you are checking it with a of 1. So the temp is equal to, temp means it is the first node. Okay, so first node is being checked with a, take it this one as key. Okay, so x is nothing but key, and temp is considered as the first element in the list. So keep that one in your mind, so it will be very easy. So temp means, so temp is the first element. Okay, so temp is the first element. So temp not equal to null. So temp then data means it can be node 1. So if node 1 double equals key element, so x is nothing but key element. So in other words, that means node 1 double equals key. So that will be given as found temp then data. If it is not found, what it should move? So it should go to temp is equal to temp then next. So temp is equal to temp means node 1. Node 1 then next will goes to node 2. Keep this one in your mind. You are under node 2. Okay, so now again you will go node 2 not equal to null. So node 2 double equals key. Okay, if it is found, it will return temp then data. If it is not found, again move to node 2 dot next. Node 2 dot next will go to node 3. Again come here, node 3 not equal to null. So again check node 3 double equals 6. So if it is found, temp then data. If not, node 2 dot next, that will go to node 3. So have you understood this program? Are you understanding? Yes, respond here. Have you understood? Okay, this is up to linear search. Now you come for the next one. So next part is reversing a linked list. So that means you are going to reverse the given linked list. So how you reverse? We can reverse a linked list by reversing the directions of the link between two nodes. That means, so node D, so you now you see node A contains the pointing to node B. Node B is pointing to node C. Node C is pointing to node D. Okay. So now if you want to reverse, just you take the reverse. So node D should point to node C. Node C should point to node B. Node B should point to node A. And node A should belong to null because you are reversing. So while you reverse, node D, last node will be pointed with null. When you reverse the output, you will get node A is pointed by the null. Understood? So that is reversing the linked list. Okay. So how you reverse? So that you have to keep in your mind. So first from D should point to C and C should point to B and B should point to A. So that is the concept. So how you do that? So now you come for the concept. So we make use of three structure pointers, says P, Q and R. Okay. So at any instant, at any time, okay, Q will point to next node of P. So at any instant, Q will point to next node to P and R will point to next node to Q. Okay. So keep in your mind, Q will point to next node to P. So which is the next node to P? So now you see first initially it is the start. Head is nothing but start node. It is pointing to node P. So node P will point to node Q and node Q will point to node R and node R will point to null. But when you reverse, what will point? So node R will point to node Q and node Q will point to node P and node P will mark it as null. Okay, so that's why we can tell node Q points to P. So that's why we are giving it as Q is equal to, keep in your mind, this is an assignment. Q is pointing to P. So Q is pointing to P and R is pointing to Q. So while you go for reverse, what you will get? R is equal to Q and Q is equal to P. That is the iteration statement. Okay, at the end, which we will change the head to the last node. So which is the last node here? According to ours, this is the last node. Okay, so P will point to null and R will point to head. So which is the head? R is the head. Okay, so now this is the concept. So now you come for this code. Okay, so first you come with a reverse word. So next you go with three pointers P, Q and R. If start double equals null, so start means, so what is the start? So in our diagram, start is equal to head. Okay, so start is equal to head here. So I will tell you like this. So if start is double equals head, okay, head is null means there is no list, so that's why we give it as list is empty. Understood? So now you come for the next one. So P is equal to start. Okay, so first you, before changing, what you will do, so you assign P is equal to start. So before changing, P is equal to start and next R is the last. Okay, R goes last, Q is the middle one, P is equal to start. Okay, so next Q is equal to P then link. So initially while moving forward, what you take? P then link is equal to Q. So where is P? P then link is pointing to Q. That is the line what I have given here. So P is containing info field and link field. So info contains some value and link, P then link is pointing to Q. So that is we have taken P then link is equal to Q. Okay. So suppose P then link is equal to null. What happens if the P then link is equal to null? There is no Q. Okay. So this can be there or may not be there also. So if P is equal to start, then you make Q is second node. Okay. So how you point the Q? P then link is equal to Q. This is the concept. We tell it as Q, P then link is equal to Q. Okay. So next, if Q not equal to null. Okay. So if Q is not equal to null means the pointer is not null, it is pointing to some other node. Okay. Yavag null irutte, that marks the end of the node Q. If the Q then link not equal, if Q not equal to null, that means it is pointing to node R. Okay. So if Q not equal to null means what the Q then link will point to? Q then link will point to R. So if Q not equal to null, Q then link will point to R. That's why we have given here it as Q then link is equal to R. Understood? So that's we have given it as Q then link is equal to R. Okay. So now you have to reverse the things. Okay, so now you have pointed, see here, P then link is equal to Q and Q is not equal to null. What you will do? You will mark it as Q then link is equal to R. Okay, so all the lines are now pointed. First you will mark P is equal to start. First you will mark P is equal to start. P then link not equal to null. Then you like P then link is equal to Q. If Q is not equal to null, then you mark Q then link is equal to R. Now you reverse the things. So how you reverse the things? So first see, this is the concept. So from here you are going to change. So first you are changing to Q then link. So where is Q then link is pointing? Q then link is pointing to R. Now you are reversing. So that means Q then link is pointing to P. So that means you are pointing Q then link is equal to P. So that's why we are given Q then link is equal to P. Okay. So next you make it P is equal to Q and Q is equal to R. So that means what you have given here, P is equal to Q. So P is equal to, that means Q is, you are making it to P and R you are making it to Q. So this is the concept. P is equal to Q and Q is equal to R. So now you make start is equal to P. So this is the concept for reverse. Okay. So first under reverse what you will do? So first you take 3 pointers P, Q, R. If A double equals null, list is empty. So if not, you will be making it as P is equal to start. Next you make P not equal to null. What you will make? P then link is equal to Q. If Q not equal to null, Q then link is equal to R. Now you reverse it. So that means R then link should point to Q. So that's why we have given R is equal to Q then link. Or you can take it R then link is equal to, Q then link is equal to R and Q then link is equal to P. So this is the conditions. So conditions for reverse. So here we are going for reverse. Q then link. So this is the conditions. Now you point substitute Q is equal to P and R is equal to Q and make start is equal to P. So this is the code for reverse. So finally you come with a complexity of various operations. Okay. So till now we have gone with operations. So insertion at beginning, end and middle. So after that you have gone with a delete at beginning, end and middle. Next you have gone with a searching and next is the indexing. What is the element? Okay, when you go with a one-dimensional array, so keep this one. It is one ID. ID is it is not. It is one-dimensional. So when you go with one-dimensional array, this is the complexities. So how much time taken? Okay, so that to insert at beginning, insert at end, insert at middle. Similarly, you see, so it will be same. For insertion at beginning, n1, n. For deletion, it is n1 and n. For search, it is going with n and log n. For indexing, it is 1. Similarly, for the singly linked list complexity, for singly linked list, so it is 1, 1. For middle, it is n. So here deletion, it is 1, n, and okay. So this representation is the complexity of various operations in array and singly linked list. Understood? So this is up to, so singly linked list. So singly linked list, we have gone up to here. So this will complete the singly linked list part. So remaining we have doubly linked list and circular linked list. So another two more concepts there in the module 2, module 3. Okay. So this will be up to singly linked list.